Hi everyone, this is Janine aka Janine the Tutor. As you know, now is a very difficult time for each one of us, whether you're in middle school, high school, or university. Many students and families are deeply affected by the recent school closure, and as a part of OneClass, we are very fortunate that we are able to adapt to the circumstance quickly. That's why we want to extend our helping hand to you students to stay on top of your studies by running free and daily classes for math and chemistry from grades 11 to first year college and university. So, without further ado, let's begin today's class. So, we will be going over geometry. So, for this class, we'll focus on trig ratios in right triangles. Okay, great. So, I just wanted to make sure that you can hear me coming through and also you can see my screen. Okay, so you've probably learned about trig ratios in class. So this is all about having SOHCAHTOA. So for example, if you have a right triangle in this case, right? So I'm just giving you an example before we dive deeper into this concept. So let's say you have 40 degrees over here. Okay, so let's say you have 40 degrees. You have a right angle over here, so you know that this is your hypotenuse, and this is 40 degrees, right? So in that case, this angle, because we need to have a sum of interior angles in a triangle, which is 180 degrees, that would be 90 plus 40, so that's 130. So 180 minus 130 is equal to 50. So we know that this must be 50 degrees. But besides that, the most important thing here is to be looking at, for example, angle A, right? And you have B, then you have C. So if you look at angle A, right? Let's say you're going to apply the trig ratios, right? If you're looking for sine A, so say for example, we're looking at angle A, in that case, you need to set up this equation in terms of the opposite side, right? So that would be line segment BC. So whatever that dimension is for line segment BC, this is going to be over your opposite side, right? Because we know that 40 degrees, the opposite side of 40 degrees would be BC or CB. And then this is going to be over your hypotenuse. So whatever the dimension is of your hypotenuse line segment AC, that's how you're going to apply this concept. And then similarly, if you're looking at cosine, because it's supposed to be a ratio, that means if you're looking at angle A, the adjacent side, so if you have cosine A, the adjacent side would simply be line segment AB, right? And this is going to be over your hypotenuse, which is line segment AC. So for tangent, right, as you can see, this is tangent. And if we're looking at tangent A, this is going to be opposite, right? So opposite side of angle A would be line segment BC, and this is going to be over your adjacent side. So adjacent side would just simply be angle AB right there. Okay, so as you notice, because we're taking the ratio between line segment BC and line segment AB, so tangent is actually sine over cosine, right? Because if you have sine, we know that this is angle BC over, sorry, line segment BC over line segment AC. And then because we're dividing, that means we're taking the reciprocal of our trig ratio for cosine. So in that case, we're multiplying this to line segment AC, right? Because we flip the positions of line segment AB and line segment AC respectively. So we would have line segment AC as your numerator, and then on the other hand, line segment AB is going to be in your denominator. And as you can see, you can cancel out line segment AC, which gives you line segment BC over line segment AB. Does that make sense? So we can actually say that tangent A is actually sine A over cosine A, which gives you line segment BC and line segment AB. So maybe I can move this just so you guys can see this. Okay, so yeah. So that's how you're going to set up your equation for tangent, because we know that it's sine over cosine. Okay, great. So since we went over a couple of things before, or maybe we have some context before we get into the actual examples, hopefully by that you have a better understanding of what SOHCAHTOA is. Let me just quickly erase this. Okay, so let's get into the examples. Oh, and by the way, I just wanted to mention, anytime we have these types of problems, especially for trig ratios, it's not necessarily just looking for the sides and the angles. It's also about how you are able to apply your Pythagorean theorem. So say for example, one side is missing, or one of your leg is missing, right? In order to find 9, right? If you recall, in that case, you would have to square 12, right? 12 squared, then you would have 9 squared, right? Which is equal to 15 squared. So you need to remember all of that, not just the trig ratios. So you can still apply your Pythagorean theorem to find your sides because you have a right triangle, right, to begin with. So that's still applicable. Okay, great. So now we're looking at sine A again. As you can see, sine A or angle A is right here, right? So first of all, if you notice, we have your trig identity, which is sine, cosine, and tangent. And inside your parenthesis would be your angle, right? So we have sine A, which means we're looking at with respect to angle A, right? So we said it was opposite over hypotenuse, so opposite would be 12, right? And your hypotenuse is 15, right? So can we simplify this because we need to reduce all fractions? Yes, right? 12 divided by 3 would be 4, then you have this divided by 3, this would give you 4 over 5, right? And then on the other hand, you would have cosine, right? So cosine is actually adjacent over hypotenuse. Remember SOHCAHTOA, so AH, right? Adjacent, and you have hypotenuse. So in that case, you would have, let me just write this. So adjacent would be this, right? 9. And this is going to be over your hypotenuse, which is 15. And just so you know, your hypotenuse never changes, right? So where exactly is your hypotenuse? So the hypotenuse of a right triangle is always opposite the 90-degree angle or the right angle, right? So you're not going to confuse the 15, right, with your other sides. Does that make sense? Because your hypotenuse in this triangle is always going to be the opposite side of your right angle, and in that case that would be side AC. So that's your hypotenuse. Okay, so simplifying this, you would divide this with 3, so you would get 3, and this is 5, right? So now you can see that sine A is actually 4 over 5, cosine A is 3 over 5. Now if we look at tangent, we know that tangent is going to be opposite, which is 12, over your adjacent side, which is 9, right? So dividing these two numbers with 3, we get 4, and this is 3, right? Alternatively, we can actually take sine A over cosine A, because remember what I said about tangent, you can have sine over cosine. So let's say we take the ratio between sine A and cosine A, and just note that because we're looking at angle A, that means you need to also be looking at the ratio between sine A and cosine A, and not some other angle in this case. So it has to be the same angle that you're looking at. So if you have sine, you would have 4 over 5, right? So this is going to be divided by 3 over 5 because that's from cosine. And as you can see, we need to multiply 4 over 5 with the reciprocal of 3 over 5, which is 5 over 3. So we would have 4 over 5 times 5 over 3. We can cancel out 5, and we see that this is 4 over 3, and this is tangent A, which is 4 over 3. Okay, great. So I don't think that was too bad. Let's move on to the second figure. So we have sine F until tangent F. So here's angle F, right? Opposite is 16, right? And first of all, let's identify what the hypotenuse is. So the hypotenuse in this case would be 20, right? Because it's the side that is opposite the right angle. So opposite side is 16, right? Opposite of angle F, and we have your hypotenuse, which is 20. So dividing this with 2, we get 8 over 10. I think we can divide this with 4, so let's try using 4. So it's quicker. So this is divided by 4, we get 4 over 5, and that's it. So for cosine F, we see that it's adjacent. So the adjacent side of angle F would be 12, right? So this is 12 over, so adjacent over hypotenuse, so that would be 20. So dividing these two numbers with 4, we get 3, and this is 5, right? 3 over 5. Now, if you're looking at tangent F, that would be opposite over adjacent, so that's opposite 16, right? Adjacent side is 12, right? So this would be divided by 2, you get 8. And let's see, divided by 2, you get 6. Divided by 2, you get 4, and this is 3. So it's 4 over 3. Yeah, it's 4 over 3, or again, you can use your ratio between sine and cosine. So you would have sine over cosine. So that's 4 over 5 divided by 3 over 5. Then you can set this up such that you would have 4 over 5. Then you're multiplying this to the reciprocal of 3 over 5, which is 5 over 3. And then you can see that it's actually 4 over 3, right? So just remember for tangent, if you don't have the information of opposite over adjacent, you can always use sine over cosine. Okay, let's look at this question. So we have Q. So angle Q is over here, and what's your hypotenuse? Your hypotenuse would be 13 because this is the side that is opposite the right angle. So if we're looking at sine Q, the opposite side of sine Q is 12, right? And opposite, and then you have your hypotenuse, right? Because sine is all about opposite over hypotenuse, so you would have 13. So for cosine, it's adjacent. So adjacent would be, so the adjacent side would be 5, right? Because we're still looking at the same angle, so that's why it's 5. And then this would be adjacent over hypotenuse, which is 13. Again, tangent, you can apply sine over cosine, right? Which is going to give you, let's see, 12 over 13. Then this is multiplied to 13 over 5, so it's supposed to be 12 over 5 for tangent. But let's say we're going to apply opposite over adjacent. So opposite of Q is 12, adjacent is 12, and this is absolutely right. So it's 12 over 5 for tangent Q. Okay, so for this triangle, so we have sine, cosine, and tangent. Now we're looking at angle M. So angle M is over here. We know that for sine, it's opposite, so that's 10 over your hypotenuse. So I know this triangle is rotated a little bit such that we're not used to seeing a triangle that has a right angle here, right? Because typically we see right triangles where you have the base, right? And also your right angle sitting upright. So in this case, we know that the hypotenuse is 26. Therefore, you need to equate this as 10 over 26 because the opposite side of angle M is 10 and your hypotenuse is 26. So dividing this with 2, right? This might be the common factor between the two. So you would have 5 and this is 13. Then if you're looking at cosine, cosine would be, the adjacent side would be 24, so 24 over 26, right? Dividing both sides with 2, you get 12, and this is 13. For tangent, opposite side would be 10, adjacent is 24, right? This is where the adjacent side is. So dividing both sides with 2, you would get 5 over 12, right? Yeah, it's right. And again, you can always use sine over cosine for tangent. Okay, so now we're looking at two different angles, right? So we have angle V and angle T, right? And also, just as a reminder, I think I've emphasized this so much. So for tangent, anytime you're equating sine over cosine, you need to make sure that if you're looking at tangent V, for example, you need to take the trig ratio between sine V and cosine v. So you cannot use other angles. So it has to be the same angle as to what you're looking for. So if you're using v, therefore it has to be sine v over cosine v. Now, if you're looking at sine v, so v is over here. This is angle v. Opposite side would be 3, and your hypotenuse, we know that it's opposite the right angle, therefore it's 5. So in that case, this is opposite over hypotenuse, so it's 3 over 5. For cosine, it would be 4. Adjacent, hypotenuse is 5, so 4 over 5. For tangent, it's going to be opposite, which is 3. Adjacent is 4, so it's 3 over 4. Again, as I mentioned, because you're specifically looking at angle v, you need to equate sine v, which is 3 over 5, divided by 4 over 5. So you take the reciprocal of 4 over 5. So it's 3 over 5 times 5 over 4. The 5 cancels out. You get 3 over 4, which is exactly what we're getting for tangent v. Okay, great. So now that we have that, let's say we have sine t. So now we'll use a different pen. So for sine t, we know that we know that angle t is over here, right? So the opposite side would be 4 now, right? But again, because we're still looking at the same triangle, that means your hypotenuse will remain the same, which is 5, right? So there's no change to your hypotenuse because it's the exact same triangle that we're looking at since earlier, right? So sine t is opposite, so that's 4 over your hypotenuse, which would be 5, right? And then if you're looking at cosine t, it's adjacent. So adjacent would be 3. Hypotenuse is 5, right? So it's over 5. And if you're looking at tangent t, it's going to be opposite, which is 4. Adjacent is 3. Great. And you know the drill for tangent, right? Tangent t, you can use sine t over cosine t. It's up to you. Okay, so for sine g, okay, so where's g? Angle g is over here. So we have opposite, so that's 40. And what's your hypotenuse? So hypotenuse would simply be this, right? Because it's the opposite side of your right angle. So we know that it's supposed to be 41. So sine g, you have opposite of g. And this is hypotenuse, which is 41. So that's it. So it's only going to be 40 divided by 41. Now, if you're looking at cosine g, it's supposed to be adjacent, which is 9 over 41, right? And if you're probably wondering if you can simplify 40 over 41 or 9 over 41, 41 is actually a prime number, so you can't really simplify these two fractions any further. So that's why you're going to keep it as 41. Okay, so if you have tangent g, that means it's the opposite side, which is 40, and your adjacent side is 9, right? So 40 divided by 9, you can't really simplify this. That's why it's only going to be 40 over 9. For sine I, let's see, it's going to be over here. So this is where sine I is, right? Or angle I specifically. We're looking at the opposite side, which is 9. Your hypotenuse is 41, right? Because again, the hypotenuse never changes because you're still looking at the same triangle. And if you're looking at cosine I, so that would be 40, so that's adjacent, 40 over hypotenuse, which is 41. Tangent I would be opposite, which is 9, adjacent is 40, because it's opposite over adjacent. So now if we have this triangle over here, right off the bat, we can see that our hypotenuse is actually 17. So if you have sine f, right, that means opposite of sine f would be 15, right? So that's 15 opposite over hypotenuse, so that would be 17. So 15 over 17. Then for cosine, it's just going to be 8, right, over adjacent over hypotenuse, which is 17, tangent f, so that's going to be opposite, which is 15 over adjacent, which is 8, right? Okay, great. You can't really simplify any of the three fractions, so we're just going to keep it as these fractions. And then if we're looking at sine h, so sine h is now here. Okay, so this is what I suggest students to do, especially when you're dealing with different angles because you're looking at two angles in this case. I know for some students it's really confusing to be looking at two angles simultaneously, especially if you're just using the same pencil, right? Because it's the same color. So I suggest you to sort of erase once you've figured out sine f. So say for example, you finish completing sine f to tangent f because during the test, especially, you don't really have time to be switching pens. That's why I highly suggest you to erase this arc over here before you move on to the next angle that you're looking at. Just so it's not confusing, right? So if you're looking at angle H, that would be opposite, so that's 8 over hypotenuse, which is 17. Cosine adjacent is 15. Then you have hypotenuse, which is 17. Again, 17 is a prime number, so you can't really simplify any of the fractions, as you can see. So then you have tangent H. Tangent H would be opposite, which is 8 over 15, which is our adjacent side. And that's it. Okay, so now we're looking at sine r and sine t, right? Okay, so for sine r, we know that sine r is right here. That means your opposite side is 35, right? And what's your hypotenuse? Your hypotenuse would be 37 because your right angle, the opposite side of your right angle, is 37. So sine r is basically 35 over 37. Cosine r is adjacent side, so that would be 12, right? And then you have 37 as your hypotenuse because cosine is adjacent over hypotenuse. And then for your tangent r, you have opposite, which is, let's see, 35, right? So that's opposite over adjacent, which is 12. Yeah, you can't simplify any fraction here. Yeah, okay. So let's move on to t. So for t, now we're looking at this angle. So opposite side would now be 12, right? Hypotenuse is 37. For cosine, it's going to be adjacent. So the side that is adjacent to angle t, so that would be 35, right? So you're probably wondering, okay, so isn't 37 also adjacent to angle t? No, because we've distinguished 37 being the hypotenuse of this triangle. Therefore, we're not going to call it the adjacent side of angle t. So we're only looking at 35. But you're right, it's an adjacent side of t, but specifically we're designating 37 being the hypotenuse of t. That's why we're not going to call it the adjacent side. So it's only going to be 35 that's adjacent to angle t. And the same thing applies for all of your angles and your sides, right? If it's the hypotenuse, therefore it's only going to be the hypotenuse. So cosine t, adjacent side is 35, hypotenuse is going to be 37. Then you have tangent t, which is opposite, so that's 12. Adjacent is 35. Okay, great. So we're done. Okay, now something is missing, right? So something is missing for number 2. It says we need to solve for x and we need to round to the 10th place if applicable. So when I say you need to round to the 10th place, that means it only applies for your sides, right? Obviously for angles, sometimes you can also have the 10th place, but let's keep your angles in terms of a whole number. So we need to solve for x, right? So first of all, you're probably wondering, okay, so what do I apply, right? Is it going to be sine? Is it going to be cosine? Or is it going to be tangent, right? So the only angles that are available right now would be 44 degrees. It would be this over here. So maybe we can look for that because we know that it's a right triangle. So we would have 180 minus 44 minus 90. So that's going to be 46. So we know that this is 46 degrees, right? So you can either use 44 degrees or 46 degrees, but I would suggest you to just use 44 degrees because you don't need to go look for 46, right? Because that's another extra step. It takes time to find that angle. So all you have to do is just take 44 degrees, right? And then think about it, right? If you have 44 degrees, what is x? X is the opposite side, right, of 44 degrees. Therefore, this is opposite right? So OPP, I'm abbreviating this being opposite. And then you have your hypotenuse, which is 18, right? So this is your hypotenuse, which is h. So that's why I know that I'm using sine 44 degrees, because I'm looking at the opposite side, which is x, and my hypotenuse is 18, right? Because otherwise, if I'm using adjacent over hypotenuse, therefore I'm using cosine. So we have this, right? How do we solve for x? All we have to do is cross multiply 18 to sine 44 degrees. And make sure your calculators are in degrees. So this would be 18 times sine 44 degrees, and that's equal to x, right? Okay, because my calculator is in radians, I need to convert this into degrees first. Okay, great. So this is 18 times sine 44 degrees. So x is equal to 12 point, because it's in the 10th place, we'll just keep this as 12.5. So it would be, so x is 12.5 inches. And also, you're welcome to use 46 degrees, so you can use x, right? You can use cosine for 46 degrees. So you can use cosine 46 degrees, which is equal to adjacent x over hypotenuse, which is 18. And then all you have to do is solve for x, the same way we're solving for sine 44 degrees, which is equal to x over 18. Great. So now we've gone through this question, so maybe we can look at the next one. Okay, so right off the bat, we see that x is our hypotenuse, right? Because that's the opposite side of our right angle. So now, how would we know which one to use, right? So remember what I said, because they're specifying that you have 58 degrees, there's no point to look for this angle, right? That means we can just use whatever we have and start from there. So we're using 58 degrees, right? So write that down. And as you can see, the adjacent side of 58 degrees would be 30, right? So adjacent, and what's your hypotenuse? Your hypotenuse, coincidentally, they're giving you this being x, right? So this is adjacent. ADJ means adjacent. I know in English it's supposed to be adjectives, but this is adjacent. So this is adjacent over hypotenuse, right? So once you have that information, then all you have to do is think about your trig ratios, right? So this has to be cosine, because if you're looking at cosine, it has to be adjacent over hypotenuse. So here's the problem, right? Because your x is in your denominator, right? So how do you solve for x now? So what you can do, this is what I tell my students: if you have a variable in your denominator and you want to turn your variable into a numerator, because that's how you're going to solve for your variable, right? You can take your reciprocal, right, for this side, and also make sure to take the reciprocal of this side, right? Why? Because you need to have a balanced equation, right? So you would have 1 over cosine 58 degrees, right? Because I'm taking the reciprocal of this, because technically it's cosine 58 degrees over 1. So taking the reciprocal of that would be 1 over cosine 58, and I'm taking the reciprocal of 30 over x. So that would be x over 30. Does that make sense? So once I know that this is existing in my numerator, this x, I can easily multiply or cross multiply 30 times 1 over cosine 58 degrees. So that would be 30 times 1 over cosine 58 degrees, and now this is equal to x. So because I want to emphasize that this is multiplication and I don't want you to think that that multiplication symbol is x, so I'm just going to enclose this in a parenthesis. Okay, great. So once we have x, we're going to take 30 times 1 over cosine 58 degrees. So x is equal to 56 point, okay, because it's in the 10th place that we need to round this off. Okay, so it's 56.61, so that would be 56.6. And this would be in millimeters. Okay, great. So now that we've solved for x, and I think that's what the instructions are telling us, only solve for x. Great. And again, you're also welcome to use this angle, right? So if you're wondering what this angle would be, you would take 180 minus 58 minus 90, so this would be 32. So you can use opposite over hypotenuse. So in this case, if you're using 32 degrees, right? How did I find 32 degrees? Then all you have to do is take 180 minus 58 minus 90, so you get the third side of your triangle. So that would result to 32 degrees. But because you're using 32 degrees, you need to use the accurate or correct trig ratio. So in this case, it would be 30, right? So it's opposite over hypotenuse. So it would be sine 32 degrees as opposed to cosine. Okay, so now let's move on to this question. So we have x over here. So now we know that the hypotenuse is 10, right? So again, as I mentioned, you don't need to look for this angle over here. I mean, don't make math too hard. You know what I mean? Because 40 degrees is just given, right? Like just use that. So you have 40 degrees, right? And this is opposite, right? It's obviously opposite because the adjacent side would be here, right? So in that case, you know that this is going to be x. Therefore, we're going to have 40 degrees, which is equal to opposite over hypotenuse, which is 10. So that's why we're using sine to solve for this. So as you can see, you can just multiply 10 times sine 40 degrees, which is x. So this is actually 6.43, so we can just keep this as 6.4 because we need to round our answer to the nearest decimal place value, which is in the tenths place. So this is 6.4, and they're not specifying any unit here, so we'll just keep it as 6.4 units. So that's what x is. Okay, great. And also, just so you're wondering, so say for example, we do find the angle here, right? And how do we find this third angle? You would just take 180 minus 40 minus 90. So that would give you 50 degrees, right? So let's say you found that this is 50 degrees and you wanted to kind of use this. You can use 50 degrees, right? But then you're going to use cosine. So you're going to say cosine 50 is equal to the adjacent side, which is x over 10. So you're not going to apply the same trig ratio that you're applying to 40 degrees because you're using a different side. Or I guess it's the same side, which is x, but with respect to 50 degrees, it's now adjacent as opposed to being opposite. Okay. So for this question, now we're looking for the hypotenuse now because we know that the hypotenuse is the side that is opposite the right angle, right? So we know that x is equal to h. Okay, great. So we have 20 degrees, right? So we're looking at the adjacent side, which is 3, and our hypotenuse is going to be x. So we can just use cosine 20 degrees, which is equal to the adjacent side, that would be 3, and our hypotenuse would simply be x. And remember what I said, anytime you have a variable, it's not restricted to just this concept, okay? So it could be like, let's say 5 over x, right, is equal to 1 over 2, right? If you wanted to isolate x, you can always flip the two equations, right? Take the reciprocal, so you would get x over 5 is equal to 2, and then you solve for x, right? So that's the way to go. So take the reciprocal, so you would have 1 over cosine 20 degrees, and that's equal to x over 3. So now that your x is in your numerator, you would just take 3 times 1 over cosine 20. Okay, so 3 times 1 over cosine 20. So this is equal to 3.2, right? So we can just keep this as 3.2 units. And again, because they're not specifying what the units are, we're just going to keep it as 3.2. Okay, so looking at this right angle, so now the missing side would be the side that is adjacent to the 90-degree angle, or the side that is opposite to 47 degrees, right? So Because we're looking at 47 degrees, again, for every single question here, you can always use the other angle, but I don't recommend that because that's just another work in terms of looking for the other angle. So just use whatever you have first, right? So if you're given 47, just go ahead and use 47 degrees first. So you're looking at 47 degrees, the opposite side is x, right? And you have an adjacent side, which is 7. So now you cannot use sine, and you can either use cosine as well, right? So that's why you're supposed to use tangent, because tangent is opposite over adjacent. So you're taking tangent 47 degrees, and you're saying this is so you're taking tangent 47 degrees, and you're saying that this is the opposite side, which is x, over your adjacent side, which is 7, right? Because we know that this is your hypotenuse over here. So you need to solve for x, therefore 7 tangent 47 degrees, right? You're multiplying 7 times tangent 47 to give you x. So this is equal to 7.5, right? So x is equal to 7.5 units, because they're not saying what the units are. Okay, great. So for the next question, yeah, we only have a couple more, so bear with me, guys. We're almost there. I know this is a very repetitive question, but again, I think being able to repeat something over and over just helps you remember it. So that's why I'm doing this. Okay, great. So you have this triangle over here. So we have 66 degrees. So the opposite side would be 12. We know that this is your hypotenuse. Why? Because you have your right angle here. So anytime you have a side that is opposite the right angle, that's exactly your hypotenuse, right? So if you have 66 degrees, you're using 12, right, and x. So first of all, 12 would be your opposite side, and then x would be your adjacent side, right? So if you have 66 degrees, the only reason why you need to turn this into your numerator is because you can only use tangent, right? There's no adjacent over opposite, right? It's only opposite over adjacent for tangent. And you can't really use cosine or sine just because you don't have your hypotenuse, and there's no point of going to look for your hypotenuse even though you're applying the Pythagorean theorem after looking for x. So that's just my opinion. So you have tangent 66 degrees, and also at the end of the day for math, you're not supposed to overcomplicate things, right? Whatever you're given, try to use them first, and if not, then find your way to get to your answer, right? So if you have tangent 66 degrees, that means opposite is 12, adjacent is x, right? So you're multiplying x times tangent 66, right? Which is equal to 12, or you can take the reciprocal, which is 1 over tangent 66 degrees, which is equal to x over 12, right? So you can take 12 times 1 over tangent 66 degrees, and that's equal to x. So let's see what x is equal to. So I'm just punching this number into my calculator. So 12 times 1 over tangent 66, this is equal to 5.3. 5.3 and units, because we don't know what the units are, right? So we're just going to say it's x is equal to 5.3 units. Okay, so you're probably wondering, if you have tangent 66 degrees, which is 12 over x, right? I know for some students, it's still a little bit harder to grasp the idea of taking the reciprocal of both sides, right, of both terms. So what if we're trying to take x, we're cross multiplying, right? So we can do that as well, right? It's fine. Let's say you have tangent 66 degrees and this is 12 over x, right? So there's a lot of ways to solve this, right? Again, I'm not pressuring you to just use my method and just blindly follow what I'm doing, because at the end of the day, I want you to understand the process of getting to the answer. Because math is not about blinding, sorry, because math is not about following your formulas blindly without even understanding it, right? I think that's the worst part when it comes to learning math. So this is what you've probably learned in class. So if you have tangent 66 degrees, which is equal to 12 over x, then if you have tangent 66 degrees, you know that this is over 1, right? So you've probably learned about cross multiplication, so you can just multiply this and this, right? So we would have x tangent 66, which is equal to, again, you're going to cross multiply 12 times 1, right? Or 1 times 12, and make sure you have that equal sign because you do have an equal sign over there. So now this is going to be 12, right? So after that, you're going to have to divide both sides with tangent 66 degrees. And now you can see that, yes, we're actually multiplying 12 times 1 over tangent 66, which is exactly what we have here, right? So 12 times 1 over tangent 66. Again, there's a lot of ways to solve for this because this is all about solving for x, right? This is algebra, so if you're comfortable using this approach, go ahead, right? I'm not pressuring you to use what I have here, but I think both ways work, so it's up to you. Just pick whichever you like. Okay, great. So maybe I can do my calculations for this triangle over here just so it doesn't get cluttered. Okay, so this will be in purple for this triangle. So now we have 75 degrees and we need to find x, right? So 48 degrees is our hypotenuse, so we can just have that h over here. So we're looking at, let's see, 75 degrees. So we're looking at the opposite side of 75 degrees. That's why we're using sine, right? So we're using sine 75 degrees over here. So the opposite side of 75 degrees is actually x. So this is x over 48, right? So 48 times 48 times sine 75 degrees, that's equal to x, right? So we know that 48 times sine 75, that's equal to, okay, so you're probably going to get a radical, right? If you have a calculator that allows you to. So this is x, which is equal to 12 squared of 6 plus 12 squared of 2, again, because they want us to keep it in terms of decimal numbers, so we're going to say that this is 46.4. And this is units, because we don't know what the units are, so we're just going to keep it as units. And it's just a side, right? So it's only units and not unit squared, because it's not an area and it's not volume. So just units. Okay, great. So we're looking at 59 degrees and we have x, which is what we know by now. Hopefully you know by now that this is your hypotenuse, because the reason being is this is the opposite side of your right angle. So now we're looking at 59 degrees and we're supposed to apply cosine, right? And why is it cosine? Because it's adjacent and your hypotenuse being the sides that you're using. So you have cosine, this is 59 degrees. Then you have your adjacent side, which is 16, and that's over your hypotenuse, which is x. So all you have to do, remember what I said, there's two ways to do this. Either you cross multiply or you just take the reciprocal of each other. So what I'm going to do, I'll have 1 over cosine, 59 degrees. And this is equal to x over 16. I'm multiplying 16 times 1 over cosine 59 degrees, and that's equal to x. So x must be x must be 31.1. And this is in terms of units. Yeah, because we don't really have any units here, so we're just going to keep it as units because we don't know if it's feet, we don't know if it's centimeters or meters or whichever unit they want us to use. Okay, so let's try this question. So we have a right angle over here. So opposite that would be x, right? So as you can see, opposite of your right angle, that's x. So that's your hypotenuse just by looking at this. and then they're telling us that this is 25 degrees, right? So the opposite side of 25 degrees is 52, right? So this is 52. So yeah, we have to use sine here, right? Because if you have sine, in that case, if you have sine 25 degrees, you're taking your opposite side, which is 52, and then your hypotenuse would be x, right? And again, remember, we can actually use this angle over here. It's up to you, right? Whichever one you prefer. So if you have sine 25 degrees, which is equal to 52 over x, then you would have x sine 25 degrees, right? Which is equal to 52 times 1, right? So I'm using the cross multiplication method here just so for the people who prefer this method as opposed to taking the reciprocal. So I'm cross multiplying x times sine 25 degrees, and I'm cross multiplying 52 times 1 because sine 25 degrees is over 1. Great, so we have that. Then we can divide both sides with sine 25 degrees. So now we'll see that x is equal to 52, right, times 1 over sine 25, or 52 over sine 25 is fine. So 52 divided by sine 25 degrees is equal to 123.0. And this is in units, right? So x is equal to 123.0 units. And just so you're wondering, let's say if we use this, right, this angle, because I haven't really done much in terms of the other angle that we're looking at, because after all, in a triangle we do have 3 angles. So let's say we want to use this one. So if we have 25, then we have 180, right? So 180 minus 25 minus 90. So in that case, the third angle must be 65 degrees. So we know that this is 65 just because the sum of the interior angles in a triangle is supposed to be 180 degrees, right? So if we take 180 minus the two sides, we get 65, right? So if you have 65, let's say you want to pick cosine, right? And why is it cosine specifically, and why not sine? Well, you don't have the opposite side of 65 degrees, right? Therefore, you're forced to use 52, which is your adjacent side, right? So that's why it's supposed to be cosine now for 65 degrees, right? And you don't have any choice. Just because you don't have the opposite side, you only have the adjacent side, which is 52. And that's going to be over your hypotenuse, because we know that SOHCAHTOA, right? CAH, so that means cosine is supposed to be adjacent over your hypotenuse. So your hypotenuse in this case would be x, right? So it's adjacent over hypotenuse. And then we're just going to solve for x. So solving for x, if we apply the cross multiplication method, right? So this is going to be cosine, and this is multiplied to x, right? Okay, so applying the cross multiplication method, we would have x times cosine 65 degrees, and that's equal to 52 times 1, because cosine 65 degrees is over 1, therefore we can say 52 times 1 is itself. Right, so once we have x, this is going to be over cosine 65 degrees, right? Divided by cosine 65 degrees. So we can say that 52 is multiplied to 1 over cosine 65 degrees, or we can just leave it like this. So we can say x is equal to 52 cosine 65 degrees. So yeah, this is the same, right? 123.0 units. So again, the two values are similar, and because they're similar, they're supposed to be identical, right? So even if we're using two different angles, right, your answer should not deviate from the other, right? Even just by a point or decimal place values, just because we're looking at the same triangle. So if we're looking at the same triangle, we're looking at the same hold on. Okay, so as I mentioned, because your x values are the same, right? It's 123 units. So the reason why they're the same is because you're looking at the same triangle, and Also, right, because if we're looking at 25 degrees, you need to assign the correct trig ratio, right? So if you're looking at 25, it must be sine because that's the only available sides that you can use. And also for cosine, 65 degrees, it has to be cosine and not other trig ratios because the only available side would be the adjacent side, right? Adjacent side to 65 degrees, and that's 52, and your hypotenuse is the one that's missing. So okay, great. So I think we've reached the end of this worksheet. Great. Yeah, so before we wrap up, I just wanted to thank you guys for, coming in on a Saturday. And if you are interested in attending more of my classes, feel free to visit this website. So it's oneclass.com/livestream. Okay. So yeah, feel free to check out this website. So oneclass.com/livestream. I do have my daily schedule. I not only teach geometry, I do teach other math courses too, like calculus. If you know anyone who's taking calculus, feel free to invite them, right? I do teach algebra too. In fact, I do have a class this afternoon at 4 p.m., so make sure to tune in. Yeah, so thank you so much for tuning in. It means a lot, and I hope you are coping through this difficult time. And remember, I'm always here for you. One Class is here for you. We're a family, so we can get through this together, and I'll see you in my next class this afternoon. Bye, guys.